The BEAT-HIV Collaboratory provides that safe space to be able to share ideas and collaborate with scientists from different backgrounds.
Learning from each other and benefiting from each other's ideas and knowledge, that's what the BEAT Collaboratory is all about.
The BEAT has invited me into the kitchen. They incorporate the community. They ask our opinions.
You know why you're doing this. You see the outcomes of the experiments that you're doing and where those new therapeutics are being applied.
BEAT-HIV is part of a national program to advance the HIV cure agenda through the Martin Delaney Collaboratory networks.
BEAT-HIV is the culmination of 25 years of collaboration between the Wistar Institute, which is a global leader in biomedical research, and Philadelphia 5 community health centers. We took all this knowledge that we've accumulated and we put this into action.
BEAT-HIV pursues 4 main objectives: how to find the virus, how to develop strategies to control the virus, how to develop strategies to eradicate and cure someone living with HIV, and how to educate and bring the community as true partners in this process. Our current understanding of how to get rid of HIV will require bringing together expertise from both eradicating the virus and empowering the human immune system to control and also contribute to the removal of the virus from the body.
HIV is integrating its own genome into the human genome. Once it's in the chromosomes, in the human chromosomes, it's not getting out anymore.
HIV-infected cells look just like uninfected cells. To specifically target them without hurting the uninfected CD4 T cells has been very, very challenging.
So a lot of the focus of our work has been on people who are living with HIV but are sort of naturally controlling it. And these people, HIV tends to be sitting in parts of the chromosomes that are not active.
The focus of my research is to understand, find, and target HIV reservoir. Using single-cell multi-omic approaches, we can identify these HIV-infected cells and understand how these cells leverage the immune programs to promote persistence.
We aim to eliminate every single virus from the body. CAR T cells, because of their sensitivity and persistence, are great candidates to achieve this goal. We just completed a phase 1 clinical trial. We had several individuals who were able to stay off their medicine during an analytical treatment interruption for up to a year.
Our lab focuses on circulating carbohydrates and metabolites, which we believe are excellent candidates to find a biomarker of how long will it take for the virus to come back after stopping therapy. So we can better select the people who are more safe to enroll in those kind of studies.
I have been working in translational HIV cure research for a while, trying to help people be able to continue to have virus suppression after various interventions. In particular, with this recent study of 2 broadly neutralizing antibodies and type 1 interferons, BEAT-HIV adds to our understanding that we can durably suppress viremia in a large proportion of people living with HIV.
In one of our first trials, we proved that by giving a combination of 2 broadly neutralizing antibodies, you maintain suppression in most of the people. However, you don't eliminate the reservoir. So we need to develop interventions that might be combined with broadly neutralizing antibodies that will help see the infected cells and eliminate the HIV reservoir.
Our laboratory has been interested in innate immunity and the natural killer cell function. It's how to use the natural killer cell as a modified killer cell as a part of the strategy. We know that the adoptive therapies with natural killer cells are better tolerated than those with T-cell strategies. One of the aspects that makes the BEAT-HIV program unique is its emphasis in social science and community engagement.
To make sure that we develop an HIV cure that is acceptable and attractive to people with HIV and also implementable in the real world, we need to integrate the perspectives of community in a systematic way. BEAT-HIV uses what's called a community engagement group that brings together scientists as well as a community advisory board to advise on current research.
Being able to ask those tough questions and being able to have them answered one-on-one, that's a fantastic reason. That's why people should be involved.
I can make a difference and let people know this is how we research and find out what we need to do to help others.
I could go out and say, hey, they could learn science won't hurt you. If you share your experience, they would say, hey, let me try.
Our collaborative research model is patient-centered. We've engaged the HIV community very early on in the design and the implementation of the study.
I'm privileged to be a co-author of our latest paper. We're reaching out to the doctors in the community just to see how do they feel about testing, how do they feel about people going off their medications.
It is my impression that the vast majority of our patients are optimistic. They feel that they are really part of something very big that will benefit the future generations to come.
For HIV providers, it's important to be able to give your patients a message of optimism, that HIV cure strategies are being tested, that we're making progress, to be able to provide tangible options for people living with HIV.
Although antiretroviral therapy is incredible and we have been able to decrease the morbidity and mortality of HIV, I think we still can do better.
The need to identify an HIV cure today is to free individuals from the burden of antiretroviral therapy and the complications that may have in their lives in the future.
Persons like myself who are living and thriving and living longer with HIV, we want cure research done. I think it'll happen in my lifetime, and I'm looking forward to that.